In this segment, we're going to talk about using value hierarchies. Value hierarchies are a very useful concept in that it allows us to decompose a more complex problem into a number of subproblems. This may be the case if we have a value proposition that has more than 3 to 5 attributes. If that's the case, we're going to run into cognitive limitations. That is, we'll be ignoring the additional attributes that exceed our 3 to 5 attribute threshold. For the elicitation of multi-attribute utility functions, this is a particular challenge since we must think about all of the attributes simultaneously. And if they're more than 3 to 5, then a decision maker is likely to neglect the least important ones, undervaluing those attributes. So for a hierarchy, the basic idea is we'd start with a top-level objective, decompose that into sub-objectives, decompose those into goals, and decompose those goals into one or more attributes, which are those metrics upon which we're going to evaluate our alternatives. And once we have a value hierarchy that represents the decomposition of different objectives to meet our ultimate top-level objective, we then need to have a basis for rolling up. That is, when we evaluate our alternatives in terms of these attributes, how do we gain that top value metric? For a value hierarchy, typically what's done is a number of weights are assigned to each of the leaves. That is, for each of the nodes on the hierarchy, we have a weight that describes the maximum value contribution of that node relative to its sister node. All of the children of a given parent have weights that add up to 1. Every one of the children node are multiplied by their weights and added up in order to aggregate up to the parent node. Imagine that we're trying to have a good house purchase. In this case, we can decompose this top-level strategic objective into having a quality house and a quality of life. Each of these objectives we can then say contributes equally, so they're assigned a weight of 1/2. Further, we can decompose having a quality house into 2 sub-goals, having a large house and having an energy-efficient house. We can assign a 3/4 weight to having a large house and 1/4 weight to energy efficient. This represents the relative contribution of each of these goals to our objective of having a quality house. Now, operationalizing having a large house, we use an attribute of square footage. This is directly measurable for our alternatives. That has a weight of 1 since it goes directly into having a large house. Now, having an energy efficient house, we can decompose into 2 attributes, annual heating cost and annual electricity cost. Each of these we feel contribute equally, so they each have a weight of 1/2. Moving on to the other branch, we have our quality of life, which we decompose into 2 goals, nearness of groceries and having social opportunities. We assign a weight of 1/4 to the groceries and 3/4 to social opportunities. We decompose our nearness of groceries to the attribute distance to market. This has a weight of 1 since it maps directly to nearness groceries. Our social opportunities is decomposed into 2 attributes, number of nearby bars within 1 mile and the average age of our neighbors. We assign a weight of 2/3 to the bar attribute and 1/3 to the age attribute. Now, there are 2 different types of weights that show up in a value hierarchy. There are local weights, which are the ones I was just talking about. Those always sum up to 1 at a given level. And we have global weights. Global weights represent the maximum value at the top that's contributed by each of the leaf nodes below. They're calculated by multiplying each parent weight by the child weight and so forth. So for this example, square footage has a weight of 6/16, annual heating cost has a weight of 1/16, annual electricity cost has 1/16, distance to groceries has 2/16, number of bars has 4/16, and age of neighbors is 2/16. The reason this matters is because it gives you insight into the relative contribution of each of the attributes to top-level value. An attribute that has a very low weight means that any performance level for alternatives on the basis is going to have very little effect on the top-level value. This allows you to prioritize your modeling efforts to focus on those attributes that are going to have the most impact. Now, one caution, using a value hierarchy in this way assumes that each attribute at the bottom level contributes independently to value at the top. Further examples of value hierarchies are found in the supplemental materials that follow.